For the first parallel port output from this stepper driver, smooth stepper, here is the first parallel port using the 25 pins ribbon cable, and it go to here. You see, an input to this breakout board here. Use the socket, and for the output of this breakout board here, lead wire is used to connect to also a socket here, so I can still use the ribbon cable here and the socket to connect it to the input of this original stepper controller board here directly. You see here, there is a socket here, 25 pin. Here you can see this. Here all the positive voltage and the ground rails are connected to this terminal box, and here I make a plastic post here on the screw nut of the screw that mounts on the transformer, and then I use this aluminum angle bracket to hold this terminal box here. This is a small 24 volt regulator, a simple circuit to support voltage for this breakout board here. You can see the 24 volt voltage. That is for the relay and the board. This was mounted. You can see the regulator. Here is the microsheet, and these aluminum pieces act as a heatsink as well. I have not enough connectors for the output, so I now manually add a pocket here. This hole was made, additional hole here to fit one more socket here. Here panels, I add one more hole here for another socket here. This additional socket is used for the connection of the cable, which routers to the panel switch. My CNC routers machines has the panel on the monitor. There are some switch I need to use cable to connect them to this controller box. Here you can see the actual hardware. Here the transformer here, this one is 24 volt by 24 volt transformer. It's about 116 VA, I think so. And this is the line filter. And this is also the filter. And these two pieces are the 5V and 12V regulator, and take care on the connection of this lead wire to this lead wire. There are many pieces of lead wire for connections. It must not be confused during disassembly and assembly. And here is the power port input here, and it uses the socket. I now disconnect it and go to my breadboard. And one thing is that the rectifier for this circuit was mounted on here on the rear aluminum plate instead, so heat can be dissipated out here. The original one is just hang on here and easily blow out. I have the experiences of 2 times in blow out the rectifier. And also here 1, 2, 3, 4 are the stepper motor driver to shiver that tap. And originally it used this little cooling fans and this U-shaped aluminum exclusion for heat dissipation. I add these 2 angle bracket here, 1, 2, to connect this side panel so the heat can further dissipate from it, because when working it continuously, much heat come out here. And here is the connection for the motor drive, for the stepper motor here. From here, all connect here. And this port is for connection for the limit switch. You can see here is 2 AC sockets for spindle and coolant. So you can use much in control the on-off of the spindle and the coolants in the program, by program. M8 and M9, I think M4, 5 something. Thank you for your watching. And these 2 pieces are regulator, IC regulator. One is for 5V and one is for 12V. And here is, in the lower diagram, it shows how the relay controls. And here is the spindle, here is the coolant. There are two toggle switch on the front panel here. So when this is turned on, 5V, there is constantly triggers the relay and has the power to them continuously. But if it is turn off, then the power will be controlled by these 2 relays, while these 2 relays will depend on the input pins on from the Mark 3. And this is a 12V power supply for this. This is for enable. When this turn on or there is enable trigger on, this will be, all the power will be activated, otherwise it will turn off. Here is the circuit board, and this two is the relay. And this is the stepper motor driver. You can see there is an enable pin. This is direction. This is the step pulse. This is the reference in STEP mode. And this is the circuit for the STEP. And this STEP, the pin for this STEP will go to the parallel port. I think is parallel port something 13 or 12 pin. This is the two emergency stop. So once this was break out, this will not be enabled. This is the output of the original parallel port. You can see is the pull up resistor here, a band of pull up resistor. This is the circuit, PCB board circuit. You can see the connection from the breakout board. There is two bunches of lead wire. Here is the first one. This is 26 pin socket. And go to parallel port. This is parallel port 2. From here, there is the breakout port, first breakout port here, and the second bunch is here. That connect to this socket. And just a reminder, here is the smoothstepper. You can see I added a clear plastic cover here. You see clearly. This top cover is plastic cover. Because it's the most expensive hardware, and it's a dedicated access. So to avoid any damage, I add the cover shields here, clear cover shield on it. Here is correct set cable connection. This is the port 1, set cable 1, and go to here and go to this first breakout port, and number 2 port is here. Correct, this is the correct position here. Previously the video was wrong. Here is number 2, number 1, number 2, 2. It will go to this here, underneath of this area, the socket here, and the third port is here, and it will go to here. These two parallel ports go to this port underneath here.